Hey everyone, welcome to O2i Institute. Have you ever seen this formula, e to the power of 1 I pi plus 1 equals 0? Yes, this is the Euler's formula, and you have probably seen it. It is one of the most beautiful and famous formulas you will ever see. However, have you ever wondered where this come from? Or simply, what does it mean? Hang on with us, I'll explain. First, we'll look into a more general form of the Euler's formula. E to the power of ix equals cosine x plus I times sine x. Okay, let's look into the right part. This seems familiar, right? If you have ever learned complex numbers or polar coordinates, you recognize that this is the polar expression of a complex number, a plus bi. Okay, in order to better understand this, let's pull out the complex plane, ix. Now we have a plus bi. This is represented by a point on the plane. And then we will have a vector pointing toward this point. And at the same time, we can label A and B. Now, we can see this is a triangle. So of course we'll have angles. So let's define the angle between the vector and the x-axis as theta. Okay, now we have angle theta. Also, we can figure out the hypotenuse. Let's say A equals to R. And by the Pythagorean theorem, we can see that R equals A squared, square root of A squared plus B squared. Now, let's try to express A plus BI in another way, which is using trigonometry. Okay, now we can express, we know cosine theta equals A over R. And then sine theta equals B over R. Now, let's reorganize this. Let's reorganize this into A equals R times cosine theta. And then B equals R times sine theta. Now we have both A and B expressed by R and theta using trigonometry. So we can rewrite A plus BI into, let's see, R times cosine theta plus I times R times sine theta. Okay, let's take out the R. We'll have R times cosine theta plus I sine theta. Now we have this form. This is pretty similar to the Euler's formula we have previously. Okay, let's pull out another blank page. Okay, as we know, let me rewrite this. Okay, e to the power of ix equals cosine x plus I times sine x. We also have A plus bi equals R times cosine theta plus I sine theta. What if, let's just assume, or let's just let R equals 1. Then we have A plus bi equals cosine theta plus I times sine theta. And let's see, this is exactly the same thing as this, which is the Euler's form. So we can write it as e to the power of I theta. Now we have this. This is pretty good because we have a complex number, same thing, essentially same thing in 3 ways, expressed in 3 ways, okay? But how does this form help? You see, this is a function. This is an exponential function. So according to the rules of exponential functions, we'll have e to the power of I alpha. If we times it by e to the power of I beta, we'll have e to the power of I alpha plus beta. Okay, this is pretty good because now if we have, for example, we have cosine, for example, ex, we have cosine alpha plus I cosine alpha. This is, as we know, this is a complex number times by another complex number, which is cosine beta plus I times sine beta. Now, without, normally we will have to open the brackets, and then we're gonna time every term by each other, right? That's time consuming. Let's just say, now we know the Euler's form. This is equal to e to the power of I alpha. This is equal to e to the power of I beta. We know this is just e to the power of I alpha plus beta. Okay, very simple. However, what if alpha plus beta equals pi? Okay, you probably cannot visualize this, so let's draw a diagram. Okay, as we know, this is a let's say ei equals e to the power of I pi. So in this case, right, alpha plus beta equals pi. Okay, and also we gotta remember that r equals 1. Okay, so this is a unit circle, r equals 1. And okay, again, those two numbers are both complex numbers. So we'll have, okay, the angle is pi. So it just means that it's like it's on the x-axis, right? It's on the x-axis. So what this number is, so we know this is the I-axis. It has no I value. It's just a real number, and it's on the other side, the negative side. So a plus bi, we know b equals 0. A just -1. So this number is actually just -1. So now we get e to the power of I pi equals -1, which is e to the power of I pi plus 1 equals 0. And this is the Euler's formula we have previously. And that's how it came from.